Neptune has been lying to us. That deep, almost perfect blue. You've seen the photographs, a smooth, featureless orb the colour of deep ocean water, peaceful, still, impossibly distant. You probably thought, calm, safe. It has the fastest winds in the solar system. Its interior may be raining diamonds. An Earth-sized storm was photographed in 1989 and had completely vanished by 1994, with no explanation. And we have been there once, a single spacecraft, a few hours, 36 years ago. Everything we know about the most violent planet in our solar system came from one afternoon. Neptune does not care that we named it. It does not care that we visited. It was doing this before the Earth had oceans, and it will be doing this long after the sun is gone. And what that single afternoon showed us was a world far stranger and far more hostile than anyone expected. Let's start with the wind. On Earth, a Category 5 hurricane, the kind that levels coastal cities, that appears on front pages as a monster swirling from space, sustains winds of about 250 kilometers per hour. That is genuinely terrifying to anyone who has stood near one. On Neptune, 250 kilometers per hour is a calm day. Neptune's winds reach 2,100 kilometers per hour, faster than the speed of sound here on Earth. Not in a localized storm, not in a temporary anomaly, just the atmosphere, doing what it normally does. A continuous wall of frozen gas moving at 600 meters per second. It is not weather, it is the permanent condition of this planet. If you stood in Neptune's atmosphere, fully shielded, somehow alive, you would not feel wind. You would feel a wall. A solid wall of frozen hydrogen and methane hitting you from one direction, at all times, at the speed of a rifle bullet. There is no calm moment. There has never been a calm moment on Neptune. That is the fastest wind ever measured anywhere in our solar system. And here is what makes it so strange. Neptune sits 30 times farther from the sun than we do. The sunlight arriving there is roughly 900 times weaker than what you feel right now. Weather on Earth is driven by solar energy, by heat differences as sunlight strikes the surface unevenly. Neptune barely receives any sunlight at all. And yet Neptune radiates more than twice the heat the sun gives it. Something inside is generating this. We don't know exactly what, we just know the result. But the atmosphere is just the surface of what Neptune is hiding. Now go deeper. Below Neptune's cloud tops, the methane layer that gives it that calm, photogenic blue, the interior becomes something beyond easy imagination. Temperatures rise sharply, pressures multiply. Somewhere between 7 and 20,000 kilometers below the surface, temperatures may approach 7,000 degrees Celsius. Deeper than any drill on Earth has ever reached. Deeper than the concept of depth means anything to a human being. Under those conditions, the carbon threaded through Neptune's interior may undergo a transformation. It may become diamonds. If you could descend, insulated past any material we have ever built, the world around you would stop making sense. The gas would thicken into liquid. The liquid would press back. And somewhere in the dark, carbon would be falling past you in crystals. Not metaphorically, literally falling. Diamonds in the dark. The models suggest that somewhere deep inside Neptune, carbon is being crushed into diamonds. They form and fall slowly through liquid metal, like rain through a summer storm. Except the rain is diamonds. The mathematics points to it. The laboratory confirms it in miniature. We don't need to be there for the evidence to be enough. Neptune may contain more diamonds inside it than there are grains of sand on every beach on Earth. We named it after the god of calm seas. Its interior may be raining gemstones. But that is not the strangest thing Neptune has ever done. When Voyager 2 photographed Neptune in 1989, it captured something extraordinary in the southern hemisphere. A massive, dark oval, swirling counterclockwise, larger than the entire planet Earth. Scientists named it the Great Dark Spot. By 1994, it was gone, not fading, not slowly dissipating over years. The Hubble Space Telescope turned toward Neptune 5 years after Voyager's flyby, and the Great Dark Spot simply was not there. Gone, the way a nightmare disappears the moment you wake up and you cannot even remember what shape it had. An Earth-sized storm, rotating at hundreds of kilometers per hour, had completely dissolved. Then, a new one appeared. Different hemisphere, different shape. As if Neptune had generated a replacement somewhere else, on its own schedule, without reason or warning. Neptune storms are not like Jupiter's Great Red Spot, which has raged for centuries with a terrible, permanent consistency. Jupiter's storm is ancient. You can track it, study it, watch it shift. There is something almost comforting about a storm that never leaves. Neptune storms appear, grow to the size of worlds, and vanish. They exist by their own rules, driven by internal processes we don't fully understand. And when they go, they leave nothing. No scar, no remnant, nothing to indicate they were ever there. There is something worse about that. At least Jupiter's storm is something you can point at. Neptune storms don't stay long enough to become familiar, and nothing about Neptune demonstrates what it truly is better than what it did to the one thing it ever called its own. Neptune has 16 known moons. The largest, Triton, is unlike any large moon anywhere in the solar system. Every large moon orbits its planet in the same direction the planet rotates. Earth's moon goes prograde. Jupiter's Galilean moons go prograde. Saturn's Titan goes prograde. That is how moons form, from the same disk of material, spinning together in the same direction. Triton orbits Neptune backwards. That single orbital fact tells you everything. Triton did not form around Neptune. It was captured, a wandering body from the Kuiper Belt, the frozen debris field beyond Neptune's orbit that strayed too close and never escaped. Neptune claimed it, and has been punishing it ever since. Tidal forces are slowing Triton's orbit. Orbit by orbit, centimetre by centimetre, it is falling inward. In approximately 3.6 billion years, Triton will cross the Roche limit, the point where Neptune's gravity overwhelms the forces holding a moon together. Neptune will tear it apart, not all at once, piece by piece. Its fragments will spread into a ring system brighter and more elaborate than what Neptune has now. The moon will become a ring. Neptune will consume what it stole. Triton will become Neptune, the thing that stole it. Neptune doesn't do anything dramatic. It just waits, stand on Triton's surface and look up. Neptune fills the sky. Not a point of light, not a distant disk, but a wall of deep blue that takes up most of what you can see. And you would be close enough to watch it slowly pulling the ground out from under your feet. Triton is a world on a death sentence, counting down orbits instead of years, falling toward the giant that stole it. Voyager 2 also found one more thing on Triton: active geysers. In the coldest environment any spacecraft had ever visited, nitrogen was erupting from the surface, plumes firing 8 kilometers into the sky. Even the doomed moon is violent. Nitrogen erupting from a frozen moon, 4.5 billion kilometers from the sun. That was not supposed to be possible. Active geology on a world with barely any heat source, driven by the faintest solar energy. Sunlight so weak it takes 4 hours to arrive. And wherever there is energy driving chemistry, even at the edge of everything, scientists ask the same question: Could the right ingredients be combining somewhere in there? We do not know. We have only been to Triton once, for a few hours. In 1989, light from the sun takes 8 minutes to reach us. It takes 4 hours and 10 minutes to reach Neptune. Right now, sunlight hitting your face will not arrive at Neptune until tonight. Voyager 2 launched in 1977 and arrived 12 years later. It spent a few hours near Neptune, photographed what it could at 25,000 miles per hour, and kept moving. There are no orbiters, no missions currently in development to place something in Neptunian orbit, though proposals exist. We looked once, 36 years ago, from a spacecraft that has now left the solar system entirely. The fastest winds in the solar system, an interior raining diamonds, storms larger than planets that appear and vanish without explanation, a doomed moon falling toward its own destruction, all of it 4.5 billion kilometers away, known only from a single afternoon. We named it after the god of the sea, calm, ancient, vast. But Neptune is none of those things. Neptune was never lying. It was always exactly what it is. We just weren't listening. Subscribe if you think the universe is too violent, too vast, and too strange to keep pretending otherwise.